welcome to another video. In this video, we are going to solve this question by Cramer's rule. But compared to earlier video, these sets of equations are a little bit different here. If you observe very carefully here, if this is equation number 1, you can see that it does not have the x and its coefficient, right? For these two equations, it doesn't have the z and the coefficient, right? But if you see this system has three unknowns. They are x, y, and z, and there are three equations. Therefore, we can solve using the Cramer's rule or other method, but in this video, we are going to use the Cramer's rule, okay? Now, according to Cramer's rule, the first thing that we need is the determinant of d, right? So the value of d is the determinant value of the coefficient of the variables, right? Therefore, let's calculate d now. D equals 2. So here the column will be x, y, and z. So in this column, I will write the x coefficients, then y and the z, okay? So do not get confused, okay? Here we don't have x, so it will be 0, then 2, then -1, right? And here we have 1, 3, and here we don't have z, so it will be 0 like that. And here we have 3 and 4 and 0. So what I want to tell is that if you come across this kind of situation where in some set there is no variable or the coefficient, you have to simply replace it by 0, okay? So this is the main goal why I'm doing this question. Now, if you observe very carefully, here these two entries are 0. So if you expand through column 3, then it will be very easy for us because we have to only account for this -1, right? Therefore, we'll expand and calculate through the column 3, okay? Therefore, expanding through C3. Now, expanding through C3, we have plus, minus, plus, okay? So plus times minus is minus 1 times, then this will get cancelled. So it will be 1 times 4 is 4 minus 3 times 3 is 9, okay? So it will be -1 times negative of 5, right? 4 minus 5, 4 minus 9 is -5, so it will be +5. So our determinant d value is +5. Now, we have to calculate dx value. So dx value is that we have to now substitute this x column, coefficients column by this total, okay? The sums. So we will have now 0, -4, 3, and rest it will be same. If we expand through C3, it will be very easy for us, okay? So we'll expand through C3. We get now -1, okay? Now this and this will get deleted, so it will be -16 minus of 3 times 3 is 9. So it will be minus of 25, so it will be +25, okay? Now for dy, we'll substitute the sum in the which has the coefficients of y. So our determinant will be 0, 1, 3, and here 0, -4, 3, then others will be same. This one also, let's expand through C3, okay? C3, we get -1. Yeah, this will get deleted. Now it will be 3 plus 12, right? 3 times 4 is -12 times minus is 12. So 12 plus 3 is +15 times -1 is just -15, okay? Now last one, our dz value. Dz is just determinant of 0, 1, 3, 2, 3, 4, and now 0, -4, 3, right? So this is our dz determinant. So it will be now, you can either expand from C1 or R1, okay? So it will be better to expand through R1 because we have to only account for these factors, right? So we have plus, minus, and plus. So by expanding through R1 now, okay, so we will have negative 2 times this, and this will get deleted. So it will be 1 times 3 is positive 3, then 3 times negative 4 is negative 12, times negative 1 is just 12, right? So it will be negative 2 times of 15, so it will be negative 30, okay? Now we have got the value of dx, dy, dz as well as d. Now Cramer's rule says that to get the value of x, we have to just take the ratio of the value of dx upon d, okay? So our dx is positive 25, then our d is positive 5, so it is just 5, right? Then our y value is just dy upon d. So what is d? D is negative 15 upon 5, right? So it will be negative 3, and our z value is dz by d, and dz value is negative 30 upon 5, right? So it will be negative 6, okay? Therefore, we have got x equals to 5, y equals to negative 3, and z equals to negative 6. Therefore, our last thing that we have left is to verify, okay? Therefore, we need to substitute the value of x, y, and z in this above equation, okay, here, and see whether it satisfies the conditions or not, okay? So for equation number 1, we have 2y minus z, okay? So we have 2 times of negative 3 minus of 6, which is negative 6 plus 6, okay, equals to 0. So 0 equals to 0. So our first equation is verified, okay? For the second equation, we have that x equals to 5, right? So 5 plus 3, then y value is negative 3, should be equal to negative 4, right? So we have 5 minus of 9 equals to negative 4. So we have negative 4 equals to negative 4, which means our second equation is also verified. Now the final one is that we have 3 times x, which means we have 3 times 5, okay? So we have 15, then we have plus 4, y value is negative 3, should be equal to 3. So we have 15 minus 12 equals to 3. So this is 3 equals to 3. Therefore, by using the value of x, y, and z here, it satisfies all of the equation. Therefore, x equals to 5, y equals to negative 3, and z equals to negative 6 is the solution of this system of linear equations. I hope you all would have enjoyed this video and knew how to solve this problem when some variables are missing in each case, but you have to just keep on substituting by 0, okay? I'll see you next video. Thank you for watching. Bye.